So we are presented with this triangle, and we are given one angle and two sides, and we need to figure out what we need to do to solve for the other two angles and the other one side. So first thing I'm going to do is I'm actually going to fill out my little table here to see what I have and what I need to find. So I know that I have angle B is 41 degrees. I know that I have angle C is 29, and I have that angle A is 13. Well, I have two sides and an angle, so it could be side-side angle, which is the ambiguous case. However, if I draw a little diagram and I show that side A is 13, side C is 29, and angle B is 41, I can actually see that this is not side-side angle. This is side, angle, side. So this is not the ambiguous case, so I don't have to worry about that. But if I think about using the law of sines for this problem, I can't, because if I have A over sine of A equals B over sine of B, that gives me two unknown variables. Same with any of these with C. To solve an equation, I need only one unknown variable. So that means I'm going to have to use law of cosines. Now for the law of cosines formulas, they all have an angle in them. Well, here, the only angle I'm given is B. So the formula I'm going to use is B squared equals A squared plus C squared minus 2AC times cosine of B. The other two formulas I could use are C squared equals B squared plus A squared minus 2AB cosine of C, or A squared equals B squared plus C squared minus 2BC cosine of A. Note how these formulas have the same variable at the front and at the back. So if we're given any blank space here, so for example, for this one, I'm looking for small b. I have side A, I have side C, I have angle B. That covers all the variables on the right-hand side of this equation. So all I need to do is plug it in. And that's exactly what I'm going to do. So I'm going to say that b squared is equal to 13 squared plus 29 squared minus 2 times 13 times 29 times the cosine of 41. That means that b is equal to the square root of all of that. So the square root of 13 squared plus 29 squared minus 2 times 13 times 29 times cosine of 41. Beautiful thing about all this is I can plug this right into my calculator. So I'm going to say that I'm going to be looking for the square root of 13 squared plus 29 squared minus 2 times, just to be safe, I'm going to put this all in parentheses actually, minus 2 times 13 times 29 times the cosine of 41. Close my parentheses there, and I'm given this. So 20.998, if we round that to the nearest tenth or even to the nearest hundredth, I'm just going to get 21.0. So I will say that small b is equal to 21. Now the beautiful thing is, once I have this side, I actually can use the law of sines. So if we want to find angle A, I could use the law of cosines, which is perfectly fine, or I could use law of sines, plug it back in, and go through the problem. Just for the sake of this video, I'm going to use law of cosines, but if I were doing this problem for myself or even in class, I would actually use law of sines, and I would say b over sine of b equals a over sine of a. So I'd say 21 over sine of 41 equals 13 over sine of A. Solve for A. But again, since this is a law of cosines video, I will keep using law of cosines. So I'm going to say that A squared equals B squared plus C squared minus 2BC cosine of A. So that gives me that 13 squared equals 21 squared plus 29 squared minus 2 times 21 times 29 cosine of A. Now, in this particular case, I actually have this cosine variable, and so I need to solve for this. So I need to isolate everything else. So what I'm going to do is I'm going to clear everything else. So I'm going to simplify this up. I'm going to clean this up a little bit. So 13 squared is 169. 21 squared plus 29 squared would give me 1282. And 2 times 21 times 29 is going to be 42 times 29, which would give me 1218. It's always 1218. Okay, and so if I'm again solving for cosine of A, what I'm going to do is I'm going to subtract 1282 on both sides. So I'm going to have 169 minus 1282. And that gives me negative 1113. To get cosine of A by itself, I'm going to divide both sides by negative 1218. So I divide that answer by negative 1218. And I get this lovely decimal. So I'm just going to write that down here, 0.914. But really, and you'll see what I'm going to do, is I'm going to take the inverse cosine of that. So if I just take the inverse cosine of the answer in my calculator, it's not going to round it off. My answer is going to be as exact as it possibly can. And so here, again, I have 23.965, which rounded would just give me 24. So A is going to be 24. To find angle C now, all I have to do is subtract the angles I already have. So 180 minus 24 minus angle B, which is 41. So if this is a triangle, angle C must be 115 degrees. And that's my completed triangle. So again, law of cosines looks like some difficult formulas, but they're actually not that bad once you recognize the patterns. Also, note that we could either solve for the constant at the front, sorry, not the constant, the lowercase variable in the front, or we could solve for the uppercase capital variable in the back of the equation. Either way works, but again, this second part here in green, if I were just going through this on my own, I wouldn't even use this, because after we find the first side, here 21 in purple, we actually can use the law of cosine, or sorry, we can use the law of sines to get the other angle, and then subtract from 180 to get angle C. The rule of thumb and the sort of cheat, if you will, is that if you have a blank space in each row, if you make this little table, you cannot use law of sines, so you must use law of cosines. After we found side B, we had this second row full. That meant that we could use law of sines, which is quicker, more efficient, and saves you time.